Hey everyone, I'm Allie. I'm the COO at Chalice Custom Algorithms, and I co-founded this company with the least knowledge about AI and algorithms as one of the three founders. I have since have learned a ton, and I know I'm going to learn more because every time I talk to Tai Lin, my brain becomes more activated. And so let's introduce Tai Lin. So Tai Lin is our lead data scientist at Chalice. She is a force to be reckoned with. She is what we call a triple threat because she is amazing at data science. She's also dangerously good at engineering, and she's going to talk more about how data science and engineering work together. And she's also been really great for us on client calls. She can explain complex things really simply. And so I am thrilled to be doing an AMA with Tai Lin for all of those reasons. So I am going to jump straight into some questions. Tai Lin, you want to say hi?
Hey everyone, like Ali said, I'm the lead data scientist here at Chalice, and thank you, Ali, for the introduction. That's flattering. I'm looking forward to introducing you guys to AI and advertising tech and answering some questions and getting everybody familiar with what we do as a company and what AI can do for the entire ad tech community.
Nice. Okay, so before we even get into advertising, ad tech, et cetera, I think it'd be great to just start with some baseline definitions. So could you walk us through what is machine learning, what are algorithms, and how do they play into this concept of AI?
Sure. I think I'm going to answer those in reverse order because I think it makes the most sense. So let's jump into AI. So artificial intelligence, it's a buzzword. We all have heard it before. What does it mean? It's just a term for techniques that help computers mimic human decisions. So how can we train a computer to make human level decisions and take advantage of computer speed and efficiency at answering these questions? So that sounds really cool, but how do we use that in practice? How can we get the computer to actually make human decisions in an informative manner in real time? So that's when we get to algorithms. You can think of algorithms as a set of instructions or rules. So let's just say I want to make some chocolate chip cookies. A recipe to make chocolate chip cookies would be considered an algorithm. It's a set of instructions to tell me how to go from A to Z and get chocolate chip cookies at the end of it, assuming I follow this correctly. Now, what does machine learning do with algorithms? We can think of it as a subset of algorithms. It's math heavy, it's based on decision rules, and the output is a decision rule on a classification algorithm, a yes, no, did somebody click on my ad, yes, no. Is it an LTV score? The machine learning algorithm can predict how valuable this customer is. Maybe it's image recognition. Is this image a dog, a human, or a butterfly? It's a very broad subset of algorithms, and we can delve into that a little bit more about what actually is impactful, what do we do with this? But that's the overview of what all of these terms mean.
Cool. So what I'm hearing is algorithms are sort of a subset of AI, and machine learning is one way to get to apply algorithms using the power of technology and automation.
Yep, exactly.
Okay, cool. We did not rehearse this, so we are doing it on the fly. All right. So Tai Lin, what are these different types of algorithms or different types of applied machine learning? I didn't even understand that there were different types of algorithms. So what are those and why do you need different types? What do you do for what?
Sure. So if you start Googling machine learning algorithms, you'll find thousands of them. So let me discuss a couple different classes of algorithms, what their use cases are, and why we use them. I think the first type is statistical methods. They're a little more what we would call old school, like linear regression. So I have a big set of data and I want to fit a line to this. Something like that, where I want to just say, all right, here's my output, here's my input, give me a prediction. These are nice and they're mathematically grounded, but what we found is that some of the more traditional statistics methods that you might learn in school don't really work well with the immense data sets that we get in advertising technology. So that brings us to another class of algorithms, which is machine learning. And this is really taking advantage of advances in computational technology. And it uses all of these great advances here to harness the math knowledge and some decision rules to really give us a great algorithm that can take a huge data set as input and then output very specific results. So an example is classification. Let's say we want to know if somebody clicked on an ad, somebody didn't. We can use something called a random forest classification algorithm. We'll input all of this data, and at the end of this, we'll get a very accurate predictive model about who's going to click on an ad. We can also do something that's not just yes and no. We can look at something like lifetime value. You could have a whole range of scores going from negative values up to maybe 100, whatever this may be. We can use another set of machine learning algorithms that are regression type, something like that. And then we can use the same type of technology in machine learning to really delve into the details of who's the most valuable customer and get accurate predictions that we can use for our campaigns. The last that I want to touch on is neural networks. These are really popular and we see a lot of people using them. What's interesting is that at Chalice, we've done a lot of research on neural networks. And what we found is that some of the more advanced machine learning models, like CatBoost, for example, are as good, if not better, at predicting conversion events and some other things than neural networks. It just depends on the type of data you're using, but we can also use them for other things like synthetic data. So if we have a client that is just launching a campaign, we don't have a whole lot of data and we need to kind of collect some more data. We don't want to take 2 weeks to do that. What we can do is use something called, again, a general adversarial neural network to generate data from our past conversions that is very similar. It's almost analogous to what we see in the real data set, but it will generate more conversion data so we can train the model to do that. It's a very powerful technique and we love using these. So lots of different options here. It's a very broad class. I would say that machine learning algorithms are primarily what we use at this point, but what's great about machine learning is that there are always advances in this technology and we're at the cutting edge of this. So if something is coming up in neural networks that's interesting, we're delving into that. It's a very exciting frontier to work on.
Cool. And are neural networks the same as deep learning?
Neural networks, they can be classified as deep learning. It's an interesting terminology. Neural networks have a broad subset there. You can use recurrent neural networks. You can use general adversarial neural networks. It depends on what you're trying to do. Deep learning can also delve into computer vision. So it depends on what the goal is there. It's similar, but not quite the same.
Cool. All right, so let's talk about all of this as it relates back to advertising. So first, just what are actual applications of algorithms in advertising?
You know what I love about AI is that it can touch almost everything. We can touch the programmatic media buying, so we can optimize to a KPI, let's say CPA. We really want to make sure that we're driving down your CPAs. We can use machine learning algorithm to do that. There are also neural networks that can do image recognition, that can work on creatives. We can use AI to tell you if you have 100 creative options, which one is the best. It's also something that can build audiences. If we're looking to target a specific audience for a political campaign, we can use AI to generate that audience and make sure that we're targeting the correct people for the correct initiative. It's as broad as you want to make it. And it's really a question of what do you want to accomplish? Let's use the correct type of AI and the correct algorithm to get you there.
That makes a lot of sense. Something just clicked for me is like, we keep seeing other companies talk about how they have AI and bring AI to advertising. And then at the end of the day, it's like, but they're just selling an audience. But I guess but that's what they're doing, right? Is using AI to create these audiences that they then go put out on the market.
Right. And AI can mean absolutely anything. It's like saying sell food. Well, what kind of food do you want? Do you want tacos? Do you want fine dining? You need to delve into the details here. Anybody can sell you AI, but is it appropriate for your company and what you're trying to accomplish? You really need to dig a level deeper and get into the actual machine learning, the algorithms, and the output of the model. That's what matters at the end of the day.
Cool. All right. So we're in custom algorithms at Chalice. Could you explain what makes an algorithm custom? And what makes an algorithm custom?
What makes an algorithm custom is best captured by what it does for your client. You could say that you want to optimize CPM. You could run it through a generic let's say a DSP algorithm, and you will get some CPM reduction. What makes us truly custom is that we look at the individual advertiser's data on a very detailed level. We look at all of the features in your data that you give us. It could be 150, it could be 300, depends on what we have to work with. We also look at what model is best for you. We've built out an automated system here at Chalice that will run this through 5 different types of models and tell us what the best path to take is from here. And then also your KPI. Maybe you want to optimize the CPM. Maybe you want to pay the best, or let's say you want to optimize the LTV per dollar. There's tons of different things that you may want to optimize to. It's not always an option with DSPs in general. What's truly custom is the level of granularity you get at all of these stages. I think the most important thing for a client to think about is, if you're selling me a custom algorithm, how does it benefit me? Well, we can go down at every level, at the modeling stage, the feature stage, and the output stage, and really fine tune it to get you exactly what you're looking for.
Cool. All right, let's jump over into the questions box. So the first question we got was, what advice would you give to a woman who is just starting out in AI?
Oh, that's excellent. So my background, I've been in math programs, statistics programs, and I spent a lot of time working with women in technology. The best advice I can give you is to network with other women in your field. You'll get invaluable advice from women who have done this before and who have been experiencing this for years. I do love that the tech industry and the ad tech industry is making significant advances in inclusivity, and they're coming on board with including women at all levels, from CEO down to just starting out. It's excellent. The next thing I would say is be confident. You had the skills to get the job. You've done all of the work. Don't doubt yourself. Everybody is going to take you seriously if you project your confidence, and that's the best thing you can do for yourself. I think also one of the best things that you can do is seek out a company that truly values your opinion regardless of your gender or race. There's more and more of those coming around, and that's the best thing that I've found for myself. I know at Chalice, everybody has been extremely supportive of everybody, regardless of your background, and it's been immensely beneficial for me.
Awesome. There's a great book called The Confidence Code that I'm just thinking could be really great reading for any woman here who's thinking about advancing her career in AI or otherwise. Great. All right, I'm going to jump back into the audience questions because I like audience questions. Like, let's keep it going. So one question we have that's probably on a lot of people's minds is, do algorithms replace humans? Or what, I think we could keep it to advertising because it probably gets a little scary talking more broadly. But yeah, what do algorithms accomplish in an advertising campaign that a human can't?
What algorithms do is they automate a lot of this decision-making processes that we don't want to deal with. We don't want to have to manually go through a billion rows of data and select who we want to serve an ad to and at what price. What that frees up everybody else to do is actually dive into the things that matter outside of this manual selection process. So from a customer success process, they'll get an AI algorithm, it's launched. They have time to dig into all of the details. Are there geos that we're underserving or overserving? Are we seeing that maybe we're paying a little too much for this subset of algorithms? Maybe our frequency's off. They're freed up to look at all of these details that they would otherwise not have time to analyze if it were not for AI sort of automating the low-level process here.
Yeah, I think
I personally had invaluable experience with some of the customer success people working in tandem with me to build an algorithm. There's a lot of things that as a non-trader, I would not pick up on. So going back and forth, there's some things that we've learned from them that we've built into our process for building algorithms.
Yeah, awesome. Actually, on the topic of cooperation or coordination, I'd love to ask you about how in creating and deploying algorithms, how do data science and engineering work together? What are the handoffs? Yeah.
Oh, that's a great question. As data scientists, we love to be handed a perfect clean data set so we can just get to work, deploy the math, deploy the, machine learning models and dig into the data. That is not the case when we get handed raw data from clients. The data is often messy, there's missing values, the data may be structured in a really strange way. If we didn't have the data engineering team, it would take us a very long time to sort all of this out and get it into a format where we could be working with it. A good example is that Chalice recently switched over to Airflow. It's an engineering product that automates the data types. So if you have, let's say, user hour of week, we want that to be integers, zip codes. You want it to look like 21236. You don't want to have anything else in there. We had one case where my data science team spent a couple hours trying to debug code because out of a 3 billion row data set, there was one value in the zip code field that had a letter in there and it messed up the entire process. What the engineering team has done has streamlined that whole process so we don't have to spend time debugging these things. It's all fed to us exactly as we need to run the models. So we can use our skill sets to build the models and use their skill sets to really get the data in the correct format. The other part of that process is always the data pre-processing, getting it in the form that the data science team needs. We also have to deploy these models. We have to get them into DSPs. If I build a model and I need to launch it to DB360 or Trade Desk, there are a ton of steps to get from my model to a format that these DSPs can digest. And the engineering team has built out much of that. If we need to deploy this for, let's say, 800 ad groups at once, that's something that is not necessarily intuitive for a data scientist. It's very engineering heavy. There's a lot that goes on the back end. And we spend a lot of time going back and forth on what does my model need to look like in order for you to productionalize this. It's also very important, I think, for the data scientist team and the data engineering team to understand what each team needs and what the process is. So we can tell the data engineering team, this is what the data needs to look like. They can tell us, all right, that's great, but here are the problems that we need to address. So we're set up to work as a team to address these problems collectively. We're not handicapping each other, asking for unreasonable things.
Yeah, interesting. Sounds like there's so much that goes on in terms of creating a custom algorithm or any algorithm, and the ability to take the math, like this perfect math, let's say it is perfect math in a random forest or cat boost model, and turn it into whatever is going to be usable and frankly, just practical for, in this case, a DSP. And that's where the engineering part comes in. That's cool.
Absolutely. We learn a lot from each other and it's great to work together as a team.
Nice. All right, let's see what else we got coming through the questions. Okay, so I would not be able to answer this question, but maybe you can, or maybe we'll have to take it as a follow-up. But the question is, do you see a difference between clean rooms and no trust crypto identity environments and the impacts on AI decisioning?
So this is an excellent example of how data science works with data engineering. That would be a follow-up for the data engineering team. They handle most of the clean room solutions. That is an excellent follow-up, and I would love to learn more about it myself, but I would have to check in with the engineering team to give an accurate answer on that.
Okay. When we post all this to social media, we can post a little post webinar or post AMA answer with our engineering team on that.
Sure. Cool. I know our SVP of engineering is familiar with this technology and will have an excellent answer. I'm just not quite in a place to answer that myself.
Awesome. Part of being a confident woman is saying when you don't have the answer and you will follow up.
Exactly. You know your limits and you who has the answers here.
Okay, so I wanted to go back to some more terms that I have heard you, Ken, our chief data scientist, and the team use about advertising data and algorithms in particular. So let's just go down the list because I think these are really interesting for explaining why advertising AI is sort of unique. So the first is, could you tell me what high cardinality means?
Sure. So let's say you have open RTB variables, you have site, you have ad format, you have supply vendor. High cardinality means that for a given variable, there are tons of values that it could take. So for sites, we could be serving tens of thousands of websites. That's what we call high cardinality in machine learning. Something like ad format, maybe you have 10, maybe you have 20, lower cardinality. But often one of the biggest hurdles in this industry is working with these very large data sets with very high cardinality, because we often have to deal with site, zip code, even supply vendors to really get an accurate algorithm to work.
Cool. So it's harder to understand math-wise something like CNN versus New York Times than like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Absolutely. Most traditional statistics methods, you're very handicapped if you want to include 10 variables that also have maybe 50,000 possible values they could take, that everything starts to break down. So at Chalice, we've had to be very thoughtful about building out our processes to handle this type of situation. It's a very difficult mathematical problem to solve.
Yep, cool. All right. I think sort of following up on that, could you tell me what an unbalanced data set is and what that means for advertising and algorithms?
Sure. So if we're advertising to CPA, CPM, it's very typical to see a relatively small amount of conversions for all ads served. We might see maybe 1,000 conversions and millions of people who just saw an ad and never did anything about it. What's difficult when you're training a machine learning algorithm is you're teaching the computer to recognize different things. We need to recognize people who didn't convert and convert. So let's think of an example. Let's say like there's an alien who's never seen dogs and cats. If I show these aliens 3 pictures of a dog and 1,000 pictures of a cat, it'll get really good at recognizing cats. But if you've only seen 3 pictures, it may be difficult to recognize dog. If we show the same alien equal amounts, 1,000 dogs, 1,000 cats, pretty easy to just distinguish and recognize. It's the same problem with machine learning algorithms. If you only have a small amount of conversions, it's difficult to make the algorithm learn who is actually going to convert. So that's one of the things that we spend a lot of time on developing in Chalice is how do we deal with this problem? How do we take a relatively small number of conversions and build machine algorithms that hone in on those and can target those accurately?
Yeah, you mentioned synthetic data before, and my understanding of that is that you're basically like creating data out of the data you already have. How do you know that that is going to work? Like how, if you're creating the data, how do you know if that's going to be effective data?
Sure, that sounds scary. Synthetic data sounds like made up. How do we know that this is actually accurate data that we can model on? There's a couple ways that we check this. It's actually a very common procedure in statistics and machine learning. There's a ton of academic literature about how to do this. So we've picked algorithms that are very good at making synthetic data. But once we develop this, let's say we have 100 conversions and we really just can't train a model on this. It's not enough to really make it distinguish clicks or anything else. What we will do is we'll feed it to something like one of our neural networks will generate synthetic data. We'll make that. It'll take these 100 samples, generate data that looks like it to feed the model so it gets a little more information to go off of. That's great. How do we know it's accurate? What we do is we have a defined set of metrics to judge this by. So we'll feed it to our machine learning model. If we do not see those metrics, meaning a meaningful threshold, we won't use that synthetic data. It's not helpful. What we found in practice is that synthetic data almost always improves the model metrics by a reasonable amount, if not a substantial amount. And we typically do like using it and we'll run with it. And then we use this to sort of kickstart campaigns with low conversion rates. And then as soon as we get more data in, we remodel and continue to work from there. But it really is letting the model and the data speak. We want to make sure that everything's meeting our metrics, and that's the most important thing.
Nice. Sort of drafting off of that, how much data do you really need to create an effective algorithm? How much data does it need to happen in the live environment for the algorithm to like learn and get smarter?
You know, I hate this question because it's one of those things where it depends on the data. Sometimes the data needs to speak for itself. In practice, we will throw out some high estimate numbers that we know will get us enough conversions to work after doing this, you know, tens to hundreds of times. I can say that maybe 1,000 conversions in the campaign, I'm almost certain this will get me a good outcome. But when it comes down to it, some data sets are more predictive than others. Some just aren't great. Sometimes we can use a low conversion rate and use synthetic data and really bump that model up, and we can run with that. But it sort of depends on the data. I think something else that's worth mentioning here is the effect size. If we're running an A to B test and the control is performing very well, we need more data to make sure that we're actually improving our model. If we're running from 0 and there's nothing to beat, it's a smaller sample set that we actually need in conversions because there's nothing to go against. Anything is improvement. So this all plays into our decision-making process.
Cool. And do you like to bake off your algorithms with other, with like the DSP algorithms or other competitor algorithms?
I do. I'm entirely too competitive for my own good. So I love a good competition. I feel like our work speaks for itself in these competitions. We always perform well. So I'm always more of the bring it on spirit, and let's make sure that if we're going to do it, we do it well.
Thanks. Okay, so I have one more question, which is, what is your favorite algorithm that you have created at Chalice?
I think my favorite is something that is relatively new in development. We are calling it our geo-pacing algorithm. And what this does is it allows us to allocate a budget to a DMA level without breaking out an ad group per DMA. It's really interesting to me because we have to develop all of our standard algorithms on top of this pacing component. So what we've developed is a pretty advanced 3-step model. We've used an autoregressive model to predict available inventory. We've used some pretty advanced optimization theory to predict how much we should pay for all of this inventory. And then we've layered on some pacing algorithms on top of that to make sure that we're meeting the daily budget, the monthly budget, and pacing accordingly. So it's been a very challenging and very interesting product. And I think it has broad appeal and a lot of use cases going forward.
Yeah, I think going back to your statement of like taking care of the manual work humans don't want to do, I don't think any human wants to set up 210 ad groups just to manage budgets, right? Like,
right, exactly. I feel like on the creator
small.
side, there are many more things they could do that are more valuable than setting up 210 ad groups. And if I can automate that and free them up to what they're actually able to do for the campaign and really use those skill sets to delve into the details of the campaign and really optimize budgets without this mind-numbing work of setting up all these ad groups, I think it's great for everybody all around.
Yeah, absolutely. Well, we're at time, but what I would say is we have a couple more questions in the chat that we could follow up when we post. In particular, I love this question. What are your favorite books in data science or business? So Tylin and I will give you guys a short list. We'll follow up on email with anyone who is here. Some silly ones, like what does Tylin's mom do for a living? I think that's an insider. Tylin's mom writes religious novels for a living. Yeah, and thank you everyone who joined. I hope that you learned as much as I did about algorithms and AI and how they apply in advertising. We will be doing a follow-up to this in the next month or so, probably getting even deeper into what this looks like in the DSPs, how we deploy it, and how you and your team could take advantage of it, either DIY or through a partner like Chalice. So again, appreciate everyone who joined. Thank you for the questions and have a great rest of your day.
Thanks so much, everyone. Great talking to everybody.
Thanks. Bye.